Yo, question 5 on the 2016 AS Physics Unit 1 paper. It is your work, energy, power question, right? It's a nice easy one. This one is a written one. 6 marks for clearly explaining about the energy transfers that would happen if this ball bearing was rolled back and forth on this little curve here. They don't want an essay as such, right? They just want it well written, no spag errors, making it clear at the points A, B and C, the energy transfers, right? So obviously at the start, when it's at rest, all of that energy is potential, gravitational potential, because it's at rest. It'll go down the ramp, get to B, and in essence, all of that potential energy will be transferred to kinetic energy when it gets down to B. And it'll have maximum kinetic energy at this point here and minimum potential energy. It'll go back up the other side of the hill. The kinetic energy will decrease as it goes up against gravity. And when it gets to that point there, for that instant it's stationary. It'll have no kinetic energy again and all potential energy. Obviously though, as it goes back and forth, it will be being resisted by friction and air resistance, and it'll probably transfer energy into a bit of sound and heat as well. So each time it does the cycle, it won't actually go up as high each time, and eventually it will come to rest at B. All of the potential and kinetic energy will have been transferred through friction, sound and heat, right? So that was enough info there to get those 6 marks. Then a mathematical question on this topic. So it's moving with constant velocity, so there's no external force acting, there's no acceleration. I've got a sled being pulled by 280 newtons at an angle of 35 degrees towards the direction of motion. State why you cannot just multiply the 280 by the distance travelled to get the amount of work done. And of course, I hope you've learnt your definitions. Work done is force times distance moved, providing it's in the direction of motion. This is not in the direction of motion. Okay? Obviously, I'm going to have to do a bit of trig and do 280 cos 35 to get it, which is what they want us to do on the next part. It takes 20 minutes to pull the sled a distance of 3 kilometers. So straight away I'm thinking, hang on, they've chucked in a time. They're going to ask me about power here. Power is work done divided by the time taken. So let's have a look. They want to know, calculate the mean power. So work divided by time taken. So the work done to move this sled a distance of 3 kilometers is 280 cos 35 to get me my component of the force in the direction of motion, multiplied by, now just get everything in SI units, 3 kilometers is 3,000 meters. That comes out to 6.88 joules. The time taken was 20 minutes. Again, get it into seconds, 20 times 60, 1200, and then do work divided by that, 6.88 divided by the amount of time, and you'll get your answer in joules per second, which of course we can then call a watt. So it was 573.4 watts. Easy peasy. Laters.